Hi, my name is GEBREGERGIS. I am a PhD student at the University of Toronto in the lab of Dr. James Robertson. I'm going to present part of my PhD project on the susceptibility of C9orf72 knockout mice to excitotoxicity. Amyotrophic lateral sclerosis is a neurodegenerative that targets upper and lower motor neurons, and FTD is another neurodegenerative disease due to the loss of neurons from the frontal and temporal lobes. The most common genetic cause of both ALS and FTD is hexanucleotide repeat expansion in the chromosome 9 open reading frame 72. C9orf72 haploinsufficiency is one of the three pathomechanisms proposed to account for C9 mutation, and this is due to transcriptional downregulation that results in a reduction in mRNA level as well as reduced C9orf72 protein. So this C9 haploinsufficiency was associated with an increase in GLUR1 AMPA receptor level. This was observed in iPSC from C9 ALS patients and human motor cortices in post-mortem studies, and C9 knockout eye motor neurons, as well as in the lumbar motor neurons of C9 knockout mouse. And this was also observed in the postsynaptic density fraction of whole brain from C9 knockout mice, and this elevation was particularly localized to the dorsal part of the hippocampus. But the consequence of elevated GLUR1 level in vivo is unknown. So in this project, I studied the susceptibility of C9 knockout mice to excitotoxicity by injecting an excitotoxicity-inducing drug known as canic acid. So following injection, I scored seizure occurrences using the Racine score. So I observed that C9 knockout mice had demonstrated higher average Racine score and average number of Racine stage 4 and stage 5 with a longer duration. In another cohort, I also injected canic acid and monitored brain activity using electroencephalography, and I found that C9 knockout mice had demonstrated a higher level of electroencephalographic stage 4 and stage 5, and this persisted even after 2 months following the canic acid injection. In a preliminary study on 2 mice, I also recorded from brain slices using extracellular recording and patch plan, and I observed that there are some alterations in C9 knockout mice, and I want to increase the number for a conclusive study. So in summary, I observed that C9 knockout mice are more susceptible to excitotoxicity compared to wild type, but in the future I will also study these mice using electrophysiological methods and behavioral batteries, and as a mechanism for the observed behavioral phenotypes, I will also study exo and endocytosis of GLUR1. Finally, I would like to thank the members of the Robertson's lab, and thank you.